Welcome to GCSE Quantitative Chemistry with Mrs. Castanera. This is Lesson 7, Calculation, Solutes, Solvents and Solutions, and it's a higher tier lesson, so it's just higher tier students that should be completing this work. So today's keywords are solute, solvent, solution, concentration, mole and mass, and we're going to highlight those. By the end of the lesson, you should be able to use all of these words confidently and know what we're doing with that. So this is the content we'll be covering today from the specification. Okay, and we're going to start with the knowledge check. We're on page 36, so pause the video whilst you complete those 8 questions. Okay, so let's review those. Question 1, define the law of conservation of mass. So that's just that the mass of the reactants must always equal the mass of the products. So before the reaction happens, that mass should be the same as after the reaction happens. Question 2, define limiting reactant. So that's the reactant that gets used up first. Question 3, define excess. So that's the reactant that does not get used up as there is more of it than required. Question 4, define MR. So MR is the relative molecular mass, where you add up the AR, the relative atomic mass, of all the atoms in the compound. Make sure you're using a pen of a different colour to tick or correct your work as we go through this, please. Question 5, state the value of a mole. So that's 6.02 times 10 to the 23, and we usually add atoms on the end because we're talking about atoms. Question 6, give the units for measuring mass. So that's grams or lowercase g. Question 7, give 2 units for measuring concentration. So that's, okay, so there are several answers available for this. So grams per decameter cubed, grams per centimetre cubed, or moles per decameter cubed, or moles per centimetre cubed. So there are 4 to choose from. Any 2 of those will get you a mark. Question 8, give the units for measuring the amount of the substance, whether that's moles or mole. So give yourself a mark out of 8 for this. So today we are going to be explaining how the mass of a solute and the volume of a solution is related to the concentration of the solution. We are also going to be able to calculate the mass of a solute in a given volume of solution of known concentration in terms of mass per given volume of solution. So this is a continuation of the previous lesson. Another opportunity to practice working through solutes, solvents and solutions. So moving on to page 37, we're going to be talking about terminology. So we have done this already, okay, previous lesson. We know that solvents are usually liquids, okay, and that a solute is usually a solid, and that they're dissolved, the solute dissolves into the solid and forms a solution. We can alter either the solute or the solvent we can change these to change the concentration of the solution. So more or less of the solute or solvent will change the solution concentration. The mass of the substance is measured in grams, the amount in moles. We know this, we've done this multiple times now. Volumes of solvents are measured in either centimetres cubed for small volumes or decameters cubed for larger volumes. Again, we did this last lesson, but we're reviewing it again. So if we know 2 of the measurements, solute, solution or solvent, then we can calculate the unknown one. So for example, to calculate concentration, you simply have to do mass divided by volume. And the same goes to resistance. To calculate the amount of solute, it's concentration times volume. Mass of solute is concentration times volume, same as mass and amount, they're very interchangeable. And volume of solvent is the mass or the amount divided by the concentration. And this is shown in these equation triangles here. And we have, this is the dividing line, okay, so everything above is divided by everything below. And again, this is the dividing line, so everything above is divided by everything below. And this is a multiplying line, okay, so this here on the left is multiplied by the amount on the right. So very simple way to use these, you cover up what you're looking for. So if I'm looking for concentration, I cover it up, and I'm left with mass divided by volume. So concentration solution is mass divided by volume, as shown here. If I'm looking for concentration, but I have an amount in moles instead, then it's the amount divided by the volume. Again, amount divided by volume, it's shown. And I can cover up the amount if I've got that, and I'm left with concentration multiplied by volume. Same as mass. If I've got that, then it's concentration multiplied by volume. And you can use this multitude of ways. So those are all written out up there. So here's a worked example, and we've done these calculations before. Okay, we've done pages of them, so this is a good worked example. What is the concentration of sodium chloride solution in grams per decameter cubed, so that's the units they want, when 20 grams of sodium chloride is dissolved in 400 centimeters cubed of water? Okay, so first of all, we're checking to see if the units match. So we have mass in grams, okay, but the volume is in centimeters cubed, and the answer requires decameter cubed. Well, we need to convert the centimeters cubed into decameters cubed so we can do the calculation and get the concentration in the correct units. So 400 divided by 1,000, so that's 400 centimeters cubed divided by 1,000 equals 0.4 decameters cubed. We've done this several times. We should be quite good at these now. Now we use the appropriate equation or triangle. So concentration is mass divided by volume, which is going to give us 20 divided by 0.4, which gives us 50 grams per decameter cubed. And remember, you can use your calculator all the time in science lessons. Okay, so there are more worked examples here. Okay, and we have again done these before. So this time, what is the concentration? So we're looking for an equation that's concentration equals of potassium chloride solution in moles per centimeter cubed, when 0.2 moles of potassium chloride is dissolved in 2 decameter cubed of water. So let's check our units. So our concentration, we've been asked to give it in moles per centimeters cubed, but the amount of water has been given in decameters cubed. So we need to convert this amount of water into centimeters cubed, so we're giving the right correct answer. So 2 times 1,000, so it's 2 decameters cubed, multiplied by 1,000 will give us the answer in centimeters cubed. Okay, so that is 2,000 centimeters cubed. Now we need to put this new amount, so that's 2,000 centimeters cubed of water, into our equation. So we're calculating concentration, we have moles. So going back to our equation triangle, we're calculating concentration, we have an amount in moles, so it's amount divided by volume. It's also up here, concentration of solution is the amount divided by the volume. So let's go back to our equation. So our amount is 0.2 moles, and our volume is 2,000 of water. So that will give us 0.2 divided by 2,000, 0.0001 moles per decameters cubed. That's 3 zeros before the 1. And remember to use your calculator. So last worked example. So what's the mass? It wants to know what the mass is of copper sulfate to make a solution with a concentration of 2 grams per decameter cubed when dissolved in 500 centimeters cubed of water. So this is our volume here, 500 centimeters cubed, and our concentration is grams per decameter cubed. So we're going to need to do our equation here to convert it. So 500 centimeters cubed divided by 1,000 gives us 0.5 decameter cubed. So now we can work out the concentration that, because we know our concentrations in decameters cubed, so we can work out the amount in mass. So this time we're calculating mass. So let's cover up the mass on our equation triangle, and we're left with concentration multiplied by volume. It's also in this, so the mass of the solute you need is concentration multiplied by volume. So we can put that into our equation. So mass is concentration multiplied by volume. And then so concentration is 2 times 0.5, so that's the concentration in the volume, which gives us a mass of 1 gram. So that is how we do those. So on page 38, you've been given a checkpoint question, checkpoint A. So a student wants to react nitric acid with potassium hydroxide. So nitric acid and potassium hydroxide are the reactants to form potassium nitrate and water. Those are the products. So what is the balanced symbol equation for this reaction? So for A, we're looking for symbol equation. So make sure you use your symbols, make sure it's balanced. Question B, the student dissolved 14 grams of potassium hydroxide in 700 centimeters cubed of water. Calculate the concentration of the potassium hydroxide solution in grams per decameter cubed. So you need to, first of all, convert, your 700 centimeters cubed to decameter cubed. Then you need to do the calculation. C, the concentration of nitric acid was 22 grams per decameter cubed. Calculate the mass of nitric acid in 30 centimetres cubed of solution. So again, we're in centimetres cubed and we need to be in decameters cubed. So I'm going to move this up so you can see what I'm writing. This time you need to convert 30 centimetres cubed to decameters cubed, okay, before you do the calculation. And your calculation is going to be mass equals, and for B, the calculation is going to be concentration equals. Okay, so you've had your hints. Pause the video whilst you do that, and then we'll mark it together. This may take you some time. Okay, so let's go through that. A, the balance symbol equation for this reaction. Well, HNO3, that is the symbol for nitric acid. KOH is the symbol for potassium hydroxide. So K is the potassium, OH is the hydroxide. Turns into potassium nitrate, so NO3 is the nitrate part, and potassium is the K, so KNO3 is potassium nitrate, and H2O, which is water. This is a balanced form of the equation. There are no additional numbers required. So there is a mark for the reactants, for getting those correct, and a mark for getting the products correct. So that is 2 marks. Part B. So first of all, we divide it. So 700 centimetres cubed divided by 1,000 is going to give us 0.7 decameters cubed. So that's the first mark. Now, if you haven't done this way, you've just done 14 divided by 0.7, that is the alternative way to get that first mark. But if you haven't written 0.7 in there and indicated that you've done that conversion, and you've just written 20 as your answer, you would only get 1 mark. So the answer is 20, and there are 2 marks available for this question. Part C. So again, we divide our 30 by 1,000 to give us 0.03 decameters cubed. And again, if you haven't done that, but you have written 0.03 in this part of the equation, when you've done 22 times 0.03, then you can have that as your first mark instead. The answer is 0.66 grams, and 0.66 is sufficient to get the answer because they gave you the units, and you get 2 marks there. So this is out of 6. Okay, and you might notice, if you were a bit eagle-eyed there, that actually we did this already in lesson 5. So hopefully you can now do this independently and you have had a good go at it and you can do it. And it wasn't too tricky. If it was really tricky, this is still a really high-level question, but no matter how hard you found it, if you have improved and got more marks this time than you got last time, then that is all that needs to happen, and you're doing really well if you have improved since last time you did this in lesson 5. So go check that you did what you got in lesson 5 and what you got this time, and if you've improved by 2 marks or more, if that's possible, then you've done really well, and I'm proud of you for doing that. Okay, so moving on to page 39 now, and there are quite a lot of calculation problems to do here. Okay, so use all the skills that you've done, that you've got from previous questions, and use the worked examples to help you, and then work your way through these. There are 12 questions in total. If you're not confident, feel free to have a go at a few of them, pause the video again whilst you do that, and then come back and mark the first few, and then pause in between the marking. Okay, so let's review our answers to those questions. Question 1. Calculate the concentration in grams per decameter cubed when 2 grams of sodium chloride salt is dissolved in 0.2 decameters cubed of water. So as you can see, we've got the same units here. We've got grams and grams, decameter cubed and decameter cubed. So it's a very simple question. So concentration is mass divided by volume, and then that is 2 divided by 0.2. The 2 comes from the grams, that's the mass, and the volume is 0.2 decameters cubed, giving us an answer of 10 grams per decameter cubed. So that's worth 1 mark. Question 2. Okay, so it's a similar question here, except for this time, it still wants it in grams per decameter cubed. It gives you an amount in grams, mass in grams, but the units for the volume are now in centimetres cubed. So you will need to convert that. So 750 divided by 1,000 is 0.75 for the first mark. The next mark is given for the answer of 15.1. You can also get your first mark by writing 0.75 in your calculation to calculate the concentration. Okay, so this is a second way of getting that first mark. So this is also out of 2. Question 3. Okay, so calculate the concentration in moles per decameter cubed when the 10 moles of potassium chloride salt is dissolved into 20 decameters cubed of water. So we're looking pretty good here because it's in moles per decameters cubed, the units are moles and decameters cubed. So all you need to do is do the equation. So let's do that. So 10 divided by 20 is 0.5 moles per decameter cubed. So our answer is 0.5 moles per decameter cubed. And there's just 1 mark for that. Question 4. So again, we've got centimetres cubed of water and decameters cubed in our answer. So the first thing we'll need to do is convert that. So 425 centimetres cubed divided by 1,000 gives us 0.425 decameters cubed. And that is worth a mark. So then our concentration is the amount divided by volume. So the second way to earn that first mark is to do 1 divided by 0.425. And using this 0.425 shows you've done this calculation. And then your answer should be 2.35 moles per decameter cubed. So this is out of 2 marks. Question 5. Calculate the concentration in grams per decameters cubed when 0.4 grams of sodium hydroxide is dissolved on 0.5 decameters cubed of water. So again, you need to convert the amount of... Nope, you do not need to convert the amount of water. So this is absolutely fine. All the units are the same. So concentration is mass divided by volume, 0.4 divided by 0.5, and our answer is 0.8, and that is 1 mark. Question 6. Calculate the concentration in moles per centimetres cubed when 2 moles of hydrochloric acid is dissolved in 2 decameters cubed of water. So we're both using moles, but we're using centimetres cubed here and decameters cubed here. So we will need to convert that amount. So 2 decameters cubed, divide it by 1,000 to convert it to 2,000 centimetres cubed, and that's worth 1 mark. Then concentration is the amount divided by the volume. So our amount is 2 moles, our volume is 2,000 centimetres cubed, and that gives us a second opportunity to get this mark. And our answer is 0.001 moles per decameter cubed. That's 2 zeros between the decimal place and the 1. And that mark is out of 2. Question 7. Calculate the mass of the solute in 0.8 decameters cubed of 10 grams per decameter cubed copper chloride solution. So mass is in grams and the units for the concentration is in grams. The solute is measured in the volume, is measured in decameters cubed, as is the concentration. So this is a straightforward one again. So mass is concentration multiplied by volume, so that's 10 multiplied by 8, which gives us 8 grams, and that is worth 1 mark. Question 8. Calculate the amount of sodium chloride. So we need to remember that amount means moles. Okay, so the amount, we're looking for an amount in moles of sodium chloride in 20 centimetres cubed of 33 grams per decameter cubed of sodium chloride solution. So there's quite a lot to do here. So our 20 centimetres cubed is converted into decameter cubed for our concentration. And our amount is in moles, but we are giving it in grams. So there's 2 different conversions that will need to be done here. So to start with, we will turn 20 centimetres cubed into decameters cubed by dividing by 1,000. So that is 0.2 decameters cubed, and that's worth 1 mark. Next, we will do the calculation, which is concentration divided by volume to get our amount. Well, to get our mass, in fact, not amount. And that is 33, because it's 33 grams per decameter cubed, divided by 0.02, and this is a second opportunity for that first mark, gives us a value of 0.66 grams, and that is worth our second mark there. Now we have to convert our amount in grams to moles, so to do that we'll need the relative molecular mass of sodium chloride, which is 23 plus 35.5, which gives us a total relative molecular mass of 58.5. Now, To calculate that in moles, okay, to calculate this into moles, we'll need to do the mass, which is 0.66 grams, divided by the relative molecular mass of 58.5, which is another opportunity here to gain this third mark, to give us an answer of 0.011 moles. And this is out of 4. 1, 2, 3, 4. Okay, question 9. So question 9, calculate the mass, and when we talk about mass, we're looking for grams of potassium chloride, and it gives you the formula there, for 12 centimetres cubed of 0.1 moles per decameter cubed. So once again, there's a lot of work to do here. We're given our volume in centimetres cubed, but our concentration is in decameters cubed. We're asked to calculate mass, but we're given it in moles per decameter cubed. So to start with, we will convert our 12 centimetres cubed into decameters cubed. So 12 divided by 1,000 gives us 0.012 decameters cubed for our first mark. Then mass is, well, actually it's not going to be mass at this point, it's actually amount. So the amount is going to be concentration multiplied by the volume, and that is 0.1, because it's moles per decameter cubed, that's the concentration, multiplied by 12, multiplied by 0.012 decameters cubed, is going to give us 0.0012 moles. So there are 2 zeros between the decimal place and the 12, and that's worth the second mark. There's another opportunity here to collect the first mark, because that shows you've done the calculation there. So now we've got our answer in moles, we need to convert it into grams. So the relative molecular mass of potassium chloride is 39 for the potassium and 35 for the chloride, or chlorine, giving us 74.5, and that's worth a mark. To calculate mass, we do moles multiplied by the relative molecular mass, and we have 0.0012 moles multiplied by 74.5. So again, there's a second opportunity to get this third mark, giving us an answer of 0.09 grams, making this out of 4, so for 1, 2, 3, 4 marks. Question 10, calculate the mass, so that's grams, of sodium chloride in 2 centimetres cubed of 0.4 mole per decameter cubed of sodium chloride solution. So we're going to start by converting that, because we've got centimetres, needs converting to decameters. So 2 centimetres cubed divided by 1,000 is 0.002 decameters cubed. There are 2 zeros between the decimal place and the 2 for the first mark. Then mass, well actually in this case it's not mass, is it? It's amount. So amount is concentration multiplied by volume, so that's 0.4 multiplied by 0.002, and that's a second opportunity to get this first mark, gives us 0.0008 moles. Now that's 3 zeros between the decimal place and the 8. And that's our second mark. Now it says in moles, we need it in mass. So to convert that, we first of all need the relative molecular mass of sodium chloride, which is 58.5, which we've already calculated in question 8. And mass is moles multiplied by the relative molecular mass. So that is 0.0008 multiplied by 58.5, and this is a second opportunity to get this third mark here, giving us a value of 0.047 grams. That's 1 zero between the decimal place and the 47. And that is another question out of 4. Question 11. Calculate the volume of solvent needed to make a 2 grams per decameter cubed solution with 2 moles of magnesium chloride, and it gives us the formula. So here we're given it in grams, but we're also given our solution in moles. So first of all, we'll need to calculate the relative molecular mass of magnesium chloride, which is 24 for the magnesium and 2 lots of 35.5 for the chlorine, giving us a total relative molecular mass of 95. And that's worth a mark. Now 1 mole of magnesium chloride is 95 grams, that's not worth a mark. However, to say that 2 moles of magnesium chloride is 190 grams, that is worth a mark. Then volume is mass divided by concentration. Now our mass is 190 grams because it's 2 moles of magnesium chloride, and it's divided by 2, our concentration, which gives us 95 decameters cubed. So this one's out of 3. There's another opportunity here to earn this second mark, showing the 190. So that's out of 3. Question 12. Calculate the volume again, that could be centimetres cubed or decameter cube, you get to decide what's most appropriate, of solvent needed to make a 2 moles per decameter cubed solution with 40 grams of magnesium chloride, and it gives you the symbols for that. So the relative molecular mass of magnesium chloride is 24 for the magnesium, plus 2 lots of 35.5 for the chloride, gives us a total of 95, which is the same from last time. Okay, you still get a mark for it. Next part, 1 mole of magnesium chloride is 95 grams, so 40 grams of magnesium chloride, this is a bit trickier, is 0.42 moles. So if you've calculated that is 0.42 moles, you've done really well. Now, the way we got that is we took the amount of grams we had, which is 40, we divided it by the total for 1 mole, which was 95, and that gives us a value, and that value is 0.421, goes on a bit, so we're going to round that to 0.42 moles. So that's how we calculated that. Now, there are no marks for that, okay, for showing this part, but I want to show you how we got there. So 40 grams of magnesium chloride is 0.42 moles of magnesium chloride. So to calculate the volume, it's amount divided by concentration. Well, the amount is 0.42 moles. The concentration is 2 molar. So 0.42 divided by 2. And this is a second opportunity to show that you have calculated 0.42 moles. So it's a second opportunity for the second mark. And the answer is 0.21 decameters cubed. And you therefore are out of 3 marks. So at the end of all those questions, you'll need to give yourself a mark out of 28. If you got more than 20, then you've done exceptionally well. That was very tricky questions there, particularly questions 8, 9 and 10, which are designed to trip you up. 11 and 12 are also very difficult. If you got 10 or less, then you really need to review this, because that's too many mistakes to be making. So you need to figure out where it is you're going wrong and why. What aspect of this is it that's confusing you? So feel free to email a teacher or speak with your teacher if you are not sure where you're going wrong. We're very happy to help you. So we're now going to move on to the knowledge and application check on page 40. There are 10 questions, so I'd like to pause the video whilst you work through those, please, and then we'll go through them. Let's review the answers to the knowledge and application check. Question 1, define insoluble. So that's something that cannot be dissolved into a solvent. Question 2, define excess. That's the reactant that does not get used up as there is more of it than required. Question 3, define solvents. The solvent is the liquid used for dissolving. Question 4, define solution. So that's the solute dissolved into the solvent. Question 5, define solute. So that is the dissolved substance, or the substance to be dissolved. Question 6, convert 33 decameters cubed to centimeters cubed. So multiply it by 100 to get 33,000 centimeters cubed. Question 7, convert 200 centimeters cubed to decameter cubed. So this time we're going to divide it by 1,000 to give us 0.2 decameters cubed. Give the units for measuring concentration of solutions. So that's grams per decameter cubed and mole per decameter cubed. Those are the main ones we use, and if you have to pick one, I always recommend using those, so per decameter cubed. Occasionally people will use grams per centimeters cubed and moles per centimeters cubed, but these are better and these are the preferred option. Question 9. To make a sodium hydroxide solution, NaOH, a common alkali, crystals of sodium hydroxide are dissolved in water. A lab technician wants to make a 1 molar solution. Calculate how many grams they should dissolve in 100 centimeters cubed of water. So first of all, we calculate the relative molecular mass of sodium hydroxide. So that's 23 plus 16 plus 1, which gives us a total MR of 40. So that's worth a mark. 1 mole of sodium hydroxide is 40 grams, which is worth another mark. Now, 1,000 centimeters cubed is worth 1 decameter cubed, and so 1 mole you will need to dissolve 40 grams into 1 decameter cubed of water. So you've worked that out here and here, so there's 3 marks for this. To make potassium, question 10. To make potassium hydroxide, that's KOH, solution, a common alkali, crystals of sodium hydroxide are dissolved in water. A lab technician wants to make 0.1 molar solution. Calculate how many grams they should dissolve in 0.5 decameter cubed of water. So the MR, relative molecular mass of potassium hydroxide, KOH, is 39 plus 16 plus 1, giving us a total of 56. That's worth a mark. Now 1 mole of potassium hydroxide is 56 grams, and 0.1 mole is 5.6 grams. And in fact, you don't get a mark for that part, you get a mark for saying that 0.1 mole of potassium hydroxide is 5.6 grams. Now, because it's a 0.1 molar solution they want. 1,000 centimetres cubed is 1 decameter cubed. 0.1 mole per decameter cubed solution is going to require 5.6 grams in 1 decameter cubed. However, we only have half a decameter cubed of water, so a 0.1 mole per decameter cubed is going to require 2.8 grams, that's half the amount in half the volume. So you would need to write 2.8 grams and 0.5 decameter cubed for the answer. Okay, so this is out of 4 this time. So if you give yourself a mark out of 15, so in the first 8 questions, okay, you need to be getting 5 or more out of those 8, okay, or you need to be looking at that again for mistakes you've made and learning those. For the question 9 and 10, they're much trickier. So if you've only got a few marks on that, that's absolutely fine. But it's the first 8 questions that really you should be able to do quite easily. Okay, so that's the end of our lesson. Now, this is the last lesson in this series. However, I just wanted to draw your attention to the fact that there are several other sections to this booklet, such as the knowledge checks on page 42 and 43, the synoptic assessment on page 45 and 46, the application of knowledge questions on page 47 and 48, and the video review lesson on pages 49 and 50, which I highly recommend you do, and there is a video clip for those, which is on the document, which you will have a digital copy of, or on the paper document, which you can type in. And there are lots of questions there, and it is very, very highly recommended that you do those as part of your revision and review of this topic. If you have any questions around any of those or want any help or support from your teachers around anything in this lesson or in any of those revision resources and review resources, please feel free to email your teacher, as we're very happy to help with anything that you're stuck on or want more information on. Thank you very much.